Okay. Hi, my name's Emily, and this is my capstone project. So for the body measurements, the first things I did was download RPart and read Excel. I know that those are important. Read Excel specifically because, of course, we want to be able to read the Excel file. So we can just, oh wait, I haven't even cleared the things yet. My bad. So we can run these, and then the data file name body measurements, of course, we want that. So we're going to run that. And now it's inserted as an official Excel file for this R code. And then I wanted to name this file just body measurements so that there was no confusion. I didn't want to name it like body or just BM. Um, so that's what I'm doing right now. I named it body measurements. And then this was just to test my knowledge because I didn't think this would work, but view body measurements, and it does take me directly to the Excel file, which is nice. So I chose to do a linear regression model and a decision tree. I'll do the decision tree later. The linear regression model predicts body fat, which is what we're supposed to do, by using the variables or the coefficients. So the height, weight, stuff like that. So first, we did the LM model, which is now right here, cuts it down to 12 variables by using all of the coefficients. So this period right here is just all data from body measurements. And then we can do a summary of the LM model, and it'll give us all of the summarization, which is pretty cool how it does that in multiple ways. And then we can view the LM model, which is what we just did accidentally. So you can click it, look at the coefficients, stuff like that. And then I want to predict the body fat. So now I've done that. So now, as you can see and predict, all of the numbers are right there for each person, 252. So now we want the mean of the predictions, and a smaller mean will mean that it is closer to what the actual number is. So 1.52, that's not awful, but it's not great. It could certainly be worse. So now the decision tree, please ignore my text. I our part again. So our tree model, I'm going to use our part with body fat. Once again, there's a period and data from the body measurements Excel file. So now we have that. We have our tree model of 14 measurements. And then we want a summary of that. We can get it into the console window. Once again, it's pretty cool. You can get all this very fast. So then we want to predict the same way that we did with the linear regression. And then we're going to run that. So once again, prediction, come down here for all 252. Then we're going to do the mean just like last time to see how close it is. 3.1. That is definitely way far off compared to the other one. So the linear model was closer than the other one. Okay, now we're going to do lone result. Clean. Clean. Okay. Once again, read Excel. I don't know why I type this in so many times. I just do. Helps me focus. So loan applications, once again, we're taking it from the Excel file and I'm naming it just loan applications so I don't get confused. And then if I want to view it, I can, even though it's right there. I could also just type it in. And it shows me every single thing that is in the Excel file for loan applications. And then I learned this. I did have a lot of trouble with this assignment. So I did look up a lot of formulas that I could have used, things like this. And this formula actually came up. And to my understanding, the way that I got it was since I'm dealing with categorical data, yes or no, then it's easier to use this function, the as dot factor. So I typed it in and it worked. It changed all my numbers to be not yes and no, but to categorize them as such. So I chose logistic regression. I wanted to do a different one. This one was also challenging because I used a new function on this one too. Um, so I did the model. So GLM, loan result, all of the data from loan applications, and it's a binomial family as well. So it's very important, and it gives me a list of 30. And then if I can get a summary, just like last time, there it is, all of these numbers. I can get logistic regression prediction, which is just like I did the other time too, just to make sure to see how close they are. I apologize. Just to make sure so I can see how close they are. So we can do that. And there's all the numbers right there. But then I learned about the if-else function, which is basically the if function from Excel. That function is very helpful to me, so I have to do the classes with the if-else and turn them into yes and no. So we can run that and you can see all the numbers that are above 0.5 are y's for yes. And then the mean, we can run that 8.4, 8.5, or 0.85. That's very good. And then the decision tree is the next one I chose to do. It was just like the last one, exactly the same. So we have the tree loan, which is what I named the list, basically. List of 15, it says. Then the summary of the tree loan, I can get that. And the tree predictions, I just predicted from the tree loan from the loan applications data set using class. And then I compare that to the mean. And it's also 0.85. Um, so yeah, pretty good, pretty close. Um, but yeah, this is the model. So we can look at them really quick. And then the tree loan.